collection is not thread safe, so it's not a concurrent priority queue. And another point is that it is not stable. So if you decide to enqueue elements with equal priorities, it is not guaranteed that they would get dequeued in the same order. This is something that is generally true for most heap implementations out there. Are there any questions so far?
I mean, I'll point out that to me that means it's not a queue, but we can have that discussion later.
Sure. Cool. So that brings us to the actual API shape.
Oh, just a point of clarification.
Sure.
Did you say finding an element will be linear and not log n in the initial explanation?
Yeah, so the log n operations of a heap are, to insert an element to dequeue the smallest element. But if you wanted to like find an arbitrary element that's contained in a heap, you'd have to search for it. So hence the linear time.
Really? I thought it would be log n to find an element.
No, because you're basically
really? I thought
you're basically trying to find an element by equality. So yeah, it's not. Yeah, that's the complexity.
But isn't it just like you if it's like a max heap, then it's kind of like a binary search, and you just keep going left or right in the tree, right?
No, heaps are not they're not search trees, so you wouldn't be able to like.
Right. I mean, logically, the ones that when I studied them, it was like an array, but then you have like ordering in the array, so you know how to like skip past the elements that you don't want.
No, that's not the case. Like the heap property, the only thing that it guarantees is that the children of a given node are always larger than the node itself, but nothing else.
Okay. Cool.
Okay.
Yeah.
Okay, so maybe I should just describe the API shape as I see it. You have a priority queue class that has two type arguments, TElement and TPriority. It implements a couple of interfaces. I read-only collection of a tuple of element and priority. I expect this to be controversial and would like to discuss it with you. Like why it should be a tuple instead of a key value pair. Also implementing iCollection. It has a few constructors, so default constructor that create an empty priority queue instance, priority queue constructor that accepts a capacity parameter, priority queue constructors that accept priority comparers for the priority values, and also constructors that accept an IEnumerable of element and priority pairs, which basically implements the heapify operation.
So the default constructor, no problem. It feels like the next three can be one constructor with default parameters, and then the next two could be one constructor with default parameters.
Yeah, I wouldn't object to that.
And so like initial capacity equal -1, which is it'll do whatever it feels like doing.
Can we do other collections?
Or nullable of initial capacity. Well, we didn't have default arguments when we built any of the other collections.
Right, but like, it's weird. It's weird to me that -1 would mean.
Sure, we can use nullable of int, right? That if we want to be more clear, or we can leave it spread as 3. We like default parameters now. We didn't in the past, so I'm asking the questions. But certainly with the IEnumerable and iComparer, since the iComparer is already null for the default according to its signature, that one could just be a default parameter.
if we did that, it seems like you'd actually group the first and the third, and then the second and the fourth.
So initial capacity, comma, nullable comparer, and then IEnumerable, comma, nullable comparer.
And priority queue that takes an optional compare, right? The first and the third are just compare being optional. The second and the fourth are compare being optional, and the fifth and the sixth are compare being optional. I'm not saying we should do that, but that's the obvious pairing, right?
Yeah.
Yeah, so which one are you specifying if you want the default capacity, but to provide a custom comparer and no initial list?
The third one. Which would, if you were to combine the first and the third, it would be new priority queue, you pass in a comparer.
Oh, sorry, when you were saying first, you were actually including the default.
Yes.
That's fair. Part of why I wanted to combine using that numbering scheme, the second and third one, is so we didn't have so we had a stronger affiliation of what the first argument was, but.
Sorry, I didn't understand that. Can you elaborate?
That the first argument is either here are all of the values, which implicitly has a vague notion of capacity, though if it's enumerable and not accountable, then you don't really get a notion of capacity out of it. And then that the second parameter is the comparer, and there's not an other notion of, and the first parameter sometimes is a comparer.
I see. It just seems like for a priority queue, it seems like just like with some of our other collections, providing a comparer is probably one of the most common things that someone does with the constructor. And so having to explicitly either pass a capacity or write comparer colon seems unnecessary,
That's fair. But yeah, so basically you're saying everywhere that has a comparer, make it, or you're suggesting make all the comparers be optional, and then that collapses these 6 constructors down into 3, because
if we wanted to use default arguments, yes.
Yeah. None of them would have more than 2, which means our guidelines don't say that. Then we should have a simpler one. I mean, so yeah, really, it's do we want to leave the default one as a clean default, or do we want it to have an optional comparer? And that's a usability question that I don't think Emo has an answer to yet.
I do not.
We know that 2 default arguments is enough to confuse people. We know, but we don't know if explicitly having a default constructor is better than having a thing that has 1 default argument. Yeah, I mean, so collapsing it as the constructors isn't really a huge deal. It's just
I mean, it's reasonable that we could have 3 constructors instead of 6. But the question is there any are there any downsides to making every parameter a default parameter?
Well, your IEnumerable values you currently don't have marked as nullable, and the capacities could be.
I would probably want to keep the last 2 separate because they build a heap with in a completely different way. So
Aaron, do you want to give
I
an
wouldn't
overview of
want
the
sort of
priority
the nullability of that argument to change how the heap is constructed, if that makes sense.
Okay. I mean, if you want the 2 IEnumerable ones to be separate because of implementation reasons, then maybe we should just leave everything as is and not collapse the constructors.
Sure. Should we move on, or?
Yeah.
Seems like it.
Okay. So then you have some obvious public properties, getting the count, getting the compare that has been that is being used by the queue. I presume nothing too controversial here. Then you have the enqueue operation that, as the name explains, it accepts an element and a priority and inserts these values into the heap, which is a log n, O of log n operation. Then you have the peak operation that gives you back the element with the minimal priority, assuming that it exists. Again, this is an O of 1 operation. Then there's the dequeue method that removes the element with a minimal priority and gives it back to you. That's an O of log n operation. These are the standard heap operations that I just described. Then we have the try variants for dequeue and peak that can give you back that first of all do not throw if the heap is empty, but and also are capable of giving back the priority, assuming that you need it. You might notice that I haven't included any proper dequeue and peak methods that do give back the priority, and I'd be interested to know whether you think these might be useful.
When reading through it, I was in particular trying to figure out what's a sensible way of making a well-ordered priority queue out of this. I was like, well, if I knew what the priority was, I could know when I can like recycle some numbers, and so I need to get the priority somewhere. And then I saw the try methods, and that solved my concern. I think it's fine to have the priorities on the tries and not on the non-tries.
Okay.
Is there a cost to retrieve the priority, or is it essentially free?
I mean, apart from the copying, there shouldn't be any other cost.
So I guess what I'm asking is, would it be a good idea to have overloads that have try dequeue, or do we think it's sufficient to just use the discard operator?
I think discard should be good enough here.
Okay.
And if people complain, we can always add the overload that discards for them later.
Cool. Then there's the enqueue dequeue operation that basically implements what is otherwise known as push pop, which basically does what the name says. It pushes and pops. So it removes the minimal element from the queue and inserts the one that you provide in the argument. This is generally more efficient than doing the two operations separately, sequentially, because it basically needs to sift through the heap only once, and you also get a slight benefit if what you're trying to enqueue is actually smaller than the minimal element. Then it just gives you back the thing that you just passed through the parameters. And this is a generally useful operation, especially for certain algorithms that use priority queues. So I thought it useful to add that one as well.
Should this one have an overload that outs the current priority?
Good question. Maybe. But should it be returned as an out parameter, or should we return a tuple?
I mean, if you, so I think Steve had asked when people actually use this, and you had an example, but I didn't quite follow why it was useful. But if the belief is that most of the time no one cares, then instead of returning the tuple, which has a more complicated spill in a return, then having the out be a when you want it, then you have the extra cost as an overload seems better to me, if we're caring about perf.
Yeah, and presumably if people needed this, we could add it after the fact, right?
Sure. I mean, there's always a mild a slightly more complicated risk of breaking changes if you go from a non-overloaded method to an overloaded method. But
Sure. Yeah.
Yeah, I think
but yeah,
generally
we could add
ignore
it
that.
later.
So I have one question from chat, which is more a high-level question, but I want to ask it now so I don't forget it. And that's, do we plan on having a concurrent priority queue? Because it seems like queuing is one of those areas that is pretty common in multi-threaded environments. Or do we think the concurrent queues already have an equivalent for that?
I mean, unless someone comes up with a great parallel, algorithm or concurrent algorithm for a priority queue that is way better than just locking around every operation, I think the answer is no.
Yeah, and in general, there are many applications where a non-concurrent queue would be very useful. Sorry, a non-concurrent priority queue would be useful. So, we might consider adding a concurrent version in the future, but that goes without saying that we should still add this one.
Yeah, I have no objections. I was just forwarding the question from chat, but I think it's an interesting point.
Yeah, I mean, I think a restatement of Steve's point is, why would we make a class that has the word concurrent in it if you can get the same implementation by just putting the lock statement around your use of the existing type? If it's not better, why would we have two types?
Right.
Yeah, that's fair. I think the assumption is that somebody can cook up a smart algorithm that wouldn't do it, right?
And when they do, then we would have a reason to add it.
If we also had scenarios for it.
Yeah, it seems like queuing. I think I can buy this if you use, some sort of consumer producer scenario with priorities. That seems reasonable. But yeah, it's a non-trivial cost, so it should be more than, oh yeah, that seems plausible.
Well, and it also has to scale whatever you come up with. It has to scale better than just using locks would. So
Right.
if all you're talking about is producer consumer, I'm not sure that would, one reader, one writer. I don't even know what algorithm one uses for a thread safe priority queue.
Yeah, I mean, the scenario for thread safe priority queue would be customer service phone center where you have priority customers and, normal schlubs like us. And, lots of phone calls come in concurrently and lots of representatives are handling calls concurrently. But that could centralize mutex somewhere.
Okay. So any other questions about NQ, DQ in particular?
Yeah, so I mean, I guess I'll ask it now because it'll come up when you talked about adding and removing things. You have as an open question, should there be a remove? And it does feel like, yes, there should be a remove independent of clear, because that basically allows you to decide that if you're willing to, move something to the back of a different line and you're willing to do the linear scan to remove it, that you can do update priority. You just don't get to update priority with any notion of keeping your spot. And it's more expensive, but it's expensive when you needed the scenario instead of expensive all the time.
Yeah, I mean, the Java priority queue, which is very similar to this implementation, also adds this method, but obviously it has been strongly criticized. It is being cited as a workaround for the update mechanism, but it's also been criticized for being very slow. Like I can imagine that it would really hamper, Dijkstra's algorithm, for example, if your n is significant.
But I'm curious, why do you think remove would be useful, Jeremy? Because none of our other specialized collections offer remove in the middle. Neither queue nor stack do that.
Yes, but it's really just the workaround for it not inherently supporting update.
Yeah.
That it's. So I mean, you could still do it yourself. You'd have each of your items. you put in a wrapper where you can find the wrapper and you can just mark it as dead, and then you re-enqueue it with a new wrapper that's not dead with a different priority.
Right, but
So
I mean,
it's still something you could do, but if it has remove, even if remove is expensive, that lets you decide that you wanted a notion of updatability on an item, and so you can remove it. I mean, you could make it theoretically faster by saying you have to tell it what the current priority is, because that at least lets you stop searching. But I may be, again, like Prashant, assuming a more tree-like implementation where you can know that you've not found something.
yeah,
There are a couple of ways you could make this more efficient, like I said. So the first one is to just not use an array heap and use like a proper tree, and on each enqueue operation, just return the node of the thing that you happen to enqueue, and then you could just use that when you update the priority. But that means more allocations, obviously. The other approach is to just include a hash table inside your priority key implementation, and you'd be able to sort of quickly work out the index of the element you're trying to update relatively quickly. But that is not pay for play, because then for every enqueue operation, for every operation that happens in the heap, you would need to also update the hash table, and that comes with a non-zero cost.
Right, and that's why, yeah. So I mean, those are the costs of having a system that inherently supports updating.
Yeah.
As opposed to, fine, if you're willing to pay the linear scan cost of removing an item, then
yeah,
you can. But
if
we think it's a huge trap, and that because you said it gets criticized for being too slow, then maybe it's fine to leave off.
I feel that it might, unblock people writing algorithms in whiteboards in C#, but like if for actual applications, it might bite people. I would say we should probably include it, but our documentation should make it adequately clear what the performance cost of that operation is. The other problem, of course, is that if you have duplicate elements, like if you have, so there are two problems with this method. One is that it introduces the notion of equality for the elements themselves rather than the priorities. And the other is that if you have duplicates, then which element you end up removing is non-deterministic. It really depends on the current layout of the heap.
That's a really good reason to not add it.
Yeah.
So that's a really good reason to not add it, or it's a really good reason to add it?
To not add it.
Okay,
basically, I mean, you could. It'd be basically with remove, you would then want to presumably take a comparer so you could decide how you wanted to deal with the thing. But then if it's multiple, we need a, like, there's no notion of first, really, so you can't tell which one you really wanted to remove. So yeah, it's an easy concept, but it's a hard problem. So yeah, leaving it out seems justified then.
Yeah.
Yeah, it seems to me it's also kind of in the spirit of other collections, right? Like you could make the exact same arguments about stack, right? What if I messed up the order and I want to swap the top two elements or something, right? Like the assumption is you get your priority right up front and it's immutable, right? That's basically the data structure. And if you want to mess with that, you can, but then you have to dequeue everything up until that element and requeue everything after that element, right? And that's the same that stack or queue have today, right? So I think that's a fair assumption, because again, like if we add methods like this, I really hate that, for some super rare event later on, we now have trouble with evolving our data structure because we, supported like random or semi-random access somewhere, right?
Yeah.
I
should probably add, sorry, go ahead.
I was going to, without considering the notion of that you could have the same, even reference equals the same item at multiple priorities of, which one is it going to find and remove, and that at that moment the problem becomes complicated, and it's not the real pay for play that I felt that it was for letting somebody do an update. It's a completely different and complicated scenario, and it's a simple sounding question with a hard answer. So
I wanted to add that all of the applications I've examined that use priority updates generally implicitly assume that there are no duplicates stored in the heap. So people that want to implement Dijkstra, the issue of duplicates shouldn't be an issue for them. So I guess we might consider including it as an escape hatch, provided we adequately communicate, the problems with that method.
So is the assumption then that the T element is unique? Is that what you're saying?
Yeah, like all the applications I've seen that require some form of priority update, like they kind of assume that, if the element you've enqueued and you want to decrease its priority is 42, for example, it is generally the case that you wouldn't store the same thing twice unless there's a bug in your code, right?
Interesting. So would we detect that if you try to enqueue the element again, or would we just?
No. In general, in general, this is not something that this implementation enforces. I'm just saying that the applications that would need to remove stuff generally, like if they're enqueuing the same thing twice, they're in trouble.
I see. So our data structure would handle that. Is that the algorithm on the consumer side likely now is in trouble because they can't handle that. But like our data structure would be fine if enqueuing the same object once with priority 2, once with priority 5. That might just mean that you get the same element back twice, right?
Yeah.
Which is what you told it to do.
Yeah. But that seems fine to me. Like I would be more concerned if you enqueue something twice, but then you only get it back once with the priority you queued it in last. That would be bad.
No. That's not the case here.
Okay.
Okay. Should I keep moving down the methods then?
Yeah, I think we were at enqueue DQ, or what was the last one we looked at?
Yeah, enqueue DQ. Yeah. So next one is enqueue range, which does what you would expect. It just enqueues a sequence of element and priority pairs. Then you have the clear operation, which does what you would expect. It it empties the contents of the priority queue.
With enqueue range, do you think it's also worth having an overload that's IEnumerable of T element, comma, static T priority? Just
Sorry?
So if you want to add 20 things all at the same priority, instead of needing to do something like zip with the enumerable.repeat to make all the value tuples, would it make sense to? I agree with this one. I have a bunch of complicated things, go add them all at once. And then the other one would be go add all of these things at the same priority. Yeah.
I'm not too sure because it feels like, you just use a select to, make it work, assuming that you want to apply the same priority to everything. I don't know. Is it like a common thing?
I mean, I would. The fact that you looked at people using things, apparently not. It feels like, if you get a bunch of, if I'm thinking of things in really only 2 priority queue, right, of normal and high, and that you could get a bunch of normals coming in, and you're like, oh, go add a bunch of normals, and that if you had stuff as an enumerable of things to add, that now you need to use, you need to write an iterator method or use enumerable.repeat with enumerable.zip or whatever to make it fit this when your scenario sounds simple of go add a bunch of things at the same priority. And so it's just
it sounds reasonable. I just don't know how common it is.
Yeah, I mean, is the general expectation that priorities are somewhat unique, or is the assumption that you have always way more elements than you have priorities?
Generally, what I've seen is that priorities are numeric values and most often enums. So you tend to have like 5 or 6 bands, I guess. So in that sense, if you it might actually make sense because you might want to enqueue a batch of tasks that all have the same priority. So I don't know.
It seems that the spirit of the method here is to avoid overhead, right? And
Yeah.
so in that sense, if you generally expect to have fewer priorities than you have elements, then I think it's reasonable to have just an enumerable of T element, because otherwise you either have to enqueue multiple times or you have to do, the crazy expensive, repeat plus zip.
Yeah.
Yeah. So I think having both of them is good.
Yeah.
Sure.
I just realized I have not started taking any notes. I should probably start doing this now.
Did we talk about why using tuple instead of key value pair yet?
We have not. We could have the conversation now if you want.
Sure.
Okay, so basically, my thinking about this is that we should either use a tuple or we should use a key value pair. Now, I would say that if we end up using key value pair instead of tuple, then we should probably rename priority to key, because otherwise the API would be a bit confusing. Naming the priority queue is not unheard of in priority queues, so I guess it really is down to what you folks think.
Sorry, what was the suggestion?
So the suggestion is either we implement the priority queue as proposed here, or alternatively, if we would have the priority queue to implement I read-only collection of key value pair priority, element, then my proposal is that we should probably change the term priority and use the term key to minimize confusion. Like I kind of think that if you do .key on a key value pair to get the priority, I think that is not, I don't particularly like that.
So I would agree with that, but I think these are kind of orthogonal things. I think you could go ahead and, for example, say this guy here implements whatever the suggestion was, right, with keys and values, and then just basically do an explicit implementation so you don't actually expose keys, but you could still expose priorities, right?
Well, if you're returning a enumerable of key value pair, then element is either key or value, and priority is the other one. And it's if the API is always calling them element and priority, but you get back a key and a value, which one was which? And
yeah, exactly.
That feels fine.
So I'll say I hate value tuple in public API, and I think that this used it correctly. So
this used it incorrectly or correctly?
Correctly.
Okay.
It's the same argument as zip. There's never going to be a place that you would put unless we decided that it was going to return a thing that later might support a notion of update, which would be the only time it would gain a method. The only thing that you're doing is I need to enumerate things and I'm giving you 2 pieces of information. All you're going to do is deconstruct it, at which point value tuple is the right answer. It's only if it's going to ever want to gain helper methods or any kind of utility method or calculation properties or anything that will tie it back into this data structure, then it would want a custom type. But basically, if it's key value pair and key and value don't naturally align with what it's doing, value tuple's better.
Yeah, so I agree with that. I also think it's as you said, like the most common example is people will deconstruct it immediately, right? Like you're not going to pass this around as a tuple. In fact, many people will probably discard the priority, would be my guess, because you just want the elements.
Yeah. Now, if people agree with me and we shouldn't call a thing that can't maintain ordering at the same priority queue, and we call it priority bag, and we want to be a priority bag of key value pair, that's totally fine. But yeah, I think that creating a new type for this would be a waste, and in its current nomenclature, key value pair is wrong. So value tuple seems.
The only thing that might be surprising is when you for each over the entire queue, people might expect to get them in the order in which DQ would return them?
That's an excellent question. This is by no means guaranteed. So when you actually enumerate through the priority queue, you will get the elements in the order as stored in the heap, and therefore it would not be sorted by priority.
Right. That's yeah. I just read the comment and I was thinking. I mean, on the one hand side, it makes sense. On the other hand, it's probably surprising that the data structure only has effectively NQ and DQ semantics, and I think it would be surprising to people that the order is not the same.
Yeah. I mean, if we were to fix this, then it would be as expensive as just sorting the priority queue.
Yeah, I mean, another option you have is
it'd be more expensive, right? Because it would basically have to order n allocation.
Yeah.
Why would you have to allocate everything?
To avoid mutating the queue.
Yeah.
Yeah. Well, I mean, it.
Maybe
maybe the data structure doesn't inherently support it, but it feels like you could do a walk without mutating it, because this enumerator presumably throws if there's a concurrent modification. So all it needs is to know, what's the last thing it walked, and then do the pretend it promoted a node, which is just the iterator state.
Yeah, I don't understand the mutation argument. Like, presumably you can look at the heap data structure, and without allocating, walking it in the order in which DQ would happen, right? If somebody modifies the data structure, I mean, all bets are off, but that's true for every collection.
How do you do that? Oh, the only guarantee of the data structure is that a node is greater than, or depending on if it's min, the node is less than its children. But if the the root is 6, its furthest left node could be 10, and its furthest right node could be 3, or it could be 8. Like you don't want to, you could do it, but it would be an order n squared, right?
Well, maybe I'm not understand data structure enough, but naively I would think whatever decision we are making when we would DQ, you can predict as you're walking the data structure, no?
But DQ mutates.
Sure, but we know the behavior of the DQ, right? We know what the modification is, right?
Peak was 01. Is DQ 01?
No, it's log n.
Log n.
Okay, so then it would be at best in log n. So that. Yeah.
Okay, that makes sense.
If DQ was 01, then making an iterator seems easy, but if it's log n, then that's different.
I mean, one option you have is, instead of just implementing IEnumerable directly on the collection, you just have properties that basically give you access to, unordered elements and ordered elements, right? And then the user chooses how expensive they want it to be.
I mean, if your argument is for usability, maybe, but otherwise, or rather discoverability, but otherwise you can just do, dot order by and enumerate that.
Yeah, Mike, I guess I'm not suggesting that we offer necessarily the ordered one. It's just that I think if you just for each the queue, do we think people fundamentally understand that the order in which they get the elements back is not what DQ would have given them?
I think it would surprise many people.
Yeah. So I think Emo's suggestion is the type isn't IEnumerable or a iRead-only collection, but it has a property that has a name that implies that it's not giving you back the ordered stuff.
Exactly.
And now you see in your code, PQ dot all items unsorted, which returns an IEnumerable of whatever.
I mean, you already have elements, right? You could have elements with priorities unordered, right? Or something like this.
But that would probably be the first collection that doesn't implement some form of IEnumerable. And you wouldn't be able to, you wouldn't be able to pass the priority queue into a method that accepts IEnumerable either.
Yeah, I mean.
But you would be able to pass the priority queue dot
walk
yourself
sure.
unsortedly.
Sure, yeah.
Yeah, but that's the question, right? So if I pass it to something that takes an IEnumerable, is it correct to just get it back in an unordered fashion? I mean, the answer might be no, right? I mean, presumably you use a queue for a reason, right? You're not just putting them there for shits and giggles, right?
Yeah, Jeff asked.
I mean, you might
what's
want
the scenario for enumerating?
Yeah.
I agree that there can be some, like you want to save the state of the current, like you want to save all the data that's in the queue because your process is shutting down. Like,
right.
But what is there really a scenario for passing that as an IEnumerable? And if you do have to pass it as an IEnumerable, is it complicated to have to go through a method first? And I don't think it's too complicated, and does allow us to name the enumerable semantics.
I think not making the priority queue class itself IEnumerable makes sense, but it just feels like, is this something we've ever done before? Like, it seems like very new territory.
I mean, the question
producer
is,
consumer stuff isn't.
Yeah, I mean,
I don't think.
I think this one also is implicit.
It is like not that it's a great paradigm or a great example of design, but blocking collection implements IEnumerable, but then it also exposes a method that gives you back an IEnumerable with special semantics.
Yeah.
Yeah.
Okay.
Well, I meant the channels, pipelines, lines.
Yeah, but they also
So
not collections, right? So.
Yeah, it doesn't implement IEnumerable, but it also doesn't expose. The closest it comes is it now exposes a mutating async enumerable. That's basically like, effectively it'd be like if we expose an enumerable here, well, every time you called move next, it called DQ.
Mm-hmm.
Yeah, I mean, the only other thing I can think of is sorted dictionary, and I haven't checked, but I would be surprised if it's not, like, if the IEnumerable itself is not ordered by T-key.
I think removing IEnumerable from the class makes sense.
Yeah, I think it's fine to say, like, I think most people will probably be happy with just the elements property because they probably don't care about the priority. And I think it's somewhat easier to explain the elements themselves are not ordered because that's the same semantic you get from, let's say, dictionary, right? Because if you
they
say
might need the properties if they want to reconstruct the priority queue in a remote process.
Right, but I think if you have elements and priorities, I think it's also fine to say, look, they're not ordered, right?
I don't think priorities makes any sense. But elements and items, good luck figuring out that one. Seems reasonable.
Yeah, I'm not suggesting adding priorities. I was just thinking, like, you have two properties, elements and elements with priorities.
Okay.
And so I think that's what I'm saying. I think it's fair to say when you access these two, they are not ordered. Because that's kind of what you have with keys and values on a dictionary as well, right? You just get them in whatever order is convenient.
Yeah.
I guess I don't understand the difference between asking for elements and asking for an enumerator, and why we would expect semantics to be different between them.
Because
I think it's more
there's
like
an easier place to put documentation that says that this does not enumerate in any order that would make sense to any human in the world.
Yeah, I think that's one argument. And then the other one is also just the way you read the code, right? If you say for each var x in blah, and blah says priority queue, you would probably expect that to give you back a priority ordered.
I mean,
that may be, but then I don't know why saying for each var x in priority queue.elements, I would expect anything different.
Yeah.
I mean, that's fair. I mean, like to Jeremy's point, I mean, I'm fine, first of all, with suffixing it with unordered or something, right? Or unprioritized, whatever the phrases you want to put there. But I also think, I think IntelliSense might help you when you actually say dot, right? And then you actually see something popping up. It's a bit harder to do with interface implementations because now you have to read the remarks section on the entire data structure, which is, as I'm just experiencing, not that easy because I still can't figure out what the sort of dictionary semantics are. And I'm staring at this for 5 minutes now.
So is the proposal then to just delete enumerator. That's it. Just delete it.
Well-
That would be to remove iRead-only collection and iCollection off of the type and only
Yeah.
have them be on the.
Right. That's what I mean. Like not edit anything else. Like if you want to enumerate it, you enumerate .elements.
Yes, and then maybe an elements with priorities, right? Because people probably want to get the pairs, right? Somehow.
Yeah.
Yeah, I
So
mean, you
what-
could do a destructive, like if you're doing load save, you could do destructive. You just keep calling try dequeue to get the elements with priority so that you can write down what your state was and then rehydrate it later. But enumerating also may be sensible in that context. Yeah, so I think that just because from a documentation perspective of if it's a property, then you can document the property with saying this is unordered. But if it's but IEnumerable is, yeah, as Emo said, it's a remark in the class comment, and I think it's an easy source of confusion, especially because with small examples, it's probably really easy to accidentally get the order right. It's the same thing with people. That dictionary behaves like a list until it doesn't. But if they test it with like 4 things, it's a list. And then they get confused.
What about if I want to queue a priority queue into another one within queue range?
Then you could in queue range source queue dot elements with priority.
Yep.
We're not saying don't have the data. We're just saying don't have the type itself be enumerable.
What
Yeah. So just go through a property to get at it.
at that point do you still need elements? And then can elements with priority just be renamed, items or something? Like why have 2 enumerables, one with element and one with element and priority?
I don't know, Eric. Why do you have 2 enumerables already?
So I think that in certain cases you do not care about the priority at all. So you just want to get the elements in the queue.
Yeah, I mean, I in my case, we look at dictionary, right? It has keys and values separated out, and it's super convenient because very often you just need an enumerable for one of them, and you don't have to do the dot select.
Correct. Yeah.
I mean, I kind of agree with Jeremy's earlier comment, though. I don't think we ever need priorities by themselves. I think elements and
Yeah.
priorities is totally sufficient. But I guess 90% of the cases, people don't care about the priority; they just want the elements.
Well, I guess I'd love to understand those scenarios, because if you're enumerating the contents of the priority queue, if you care about ordering, you're going to have the priorities. If you don't care about ordering, I'm not sure why you're using priority queue.
So, I mean, the one possibility is you have 2 priority queues and you want to check for equality, and the way you do that is going through each element in priority and checking that it exists in the other one, and then vice versa.
But we don't
Right,
explicit contains, do we?
No.
But if elements is returning an unsorted list, an unsorted iterator over the elements, and you can't say that they're equal because you don't know that just because they have the same elements that they're at the same priority.
Right. I mean, you have to check both the element and you have to check for the same element and the same priority in both.
Right, which would mean that's I think Steve's question of why do we want elements as distinct from elements with priorities? Just only give the one, and if you have a scenario where you didn't care about the priority and you didn't care about the order that they came out, then just write the select statement.
Okay.
I mean, if there's a good scenario for it, great. I'm struggling to think of one.
Yeah, I think you have a good point. Like, because in my case, when I look at dictionaries, there is no order, right? I very rarely use sort a dictionary, and like in that case, it makes sense because you just treat them as sets, right? Your order doesn't matter. But yeah, I think in this case, given that you use a priority queue, it is hard to think of cases where you really don't care about the order.
Yeah, because I was going to ask the same question when we got to elements, which is what's the scenario for wanting the elements without the priorities, and I have trouble understanding why it would be common enough that we would make first class API for it.
Yeah, maybe we should just have items unordered, right? And then that just gives you back an IEnumerable of T element, comma T priority.
And that sounds good to me.
Maybe with some bike shedding on the name, but yeah.
Yeah, let's do that. This is the meeting to actually do that.
I mean, I would call it unordered items instead of items unordered, but
yeah. Or yeah, sure, that's fine.
The suffix I think would make sense if we had items, which was sorted and really expensive, and we were coming back and adding items unordered for this is the faster one if you're willing to deal with that. But otherwise, I don't think that we would add the ordered one. So I would just call it unordered items, which is the more natural English word order.
And then it returns T element, comma T priority, right?
And I something of that, whether it's the custom collection, just so it can be I read only collection and I collection, or it's I enumerable. Whichever.
Oh, I see.
Because we will know the count, so returning a thing that has that information does seem valuable.
Yeah, I guess. Let me just write I unordered items collection then, and then we can decide what that does. All right, that makes sense.
All right. So I think now we're to clear.
There are a couple of methods we haven't covered yet, but it should be real quick.
Was that possible? We just walked top to bottom.
No, we got to in-queue range and then value tuple, and then I think value tuple also then moved to the enumerability state. And so I think we skipped clear, ensure capacity, and trim access.
Yep.
I think clear, I heard him talking about, but like, I think, I think clear probably nobody has objections to, because that's pretty, pretty straightforward. Ensure
and then
capacity.
you have ensure capacity.
Yeah. The two make sense to me. Like, I mean, of course, it's predicated on the fact that you can have a sensible implementation that actually helps your performance, but presumably you do.
Mm-hmm. Does anybody think that?
Are the capacities sensible and predictable? Like, does it behave? Yeah, is the behavior like with list, or is
it follows the exact logic as list, like it doubles every time it reaches capacity.
Okay, so the capacity is only related to count. The capacity and the performance of the structure are only related to count. It doesn't need complex capacity depending on the weakness of priorities. Okay. So if that part is really just like a list, then I think yes. When I skipped over it before in the constructors and was waiting until we got to here for, can anyone actually reason about what this does? And if it's yes, then it seems good to me.
Mm-hmm.
So I'm just looking at list of T. It doesn't seem to have an ensure capacity. I think that's an internal method, I think. But it does have capacity itself as a settable property.
Well, you can pass the initial capacity, and it may have a settable property.
Yeah, which I think is, I think ensure capacity was a private helper. But I'm pretty sure we exposed it somewhere because it does sound very familiar.
Yeah. List of T capacity is get set.
Yeah, dictionary has ensure capacity. That's where. Yeah. Yeah, I think it makes sense. I mean, I think there's nothing wrong with ensure capacity. And dictionary also doesn't expose capacity either, not even as read only. So you can't even ask it. Yeah. That's a bit odd though, but I guess that's also not terrible.
I mean, I think it's one of those that, well, list returns it. I don't think most people really care. Like maybe they do if they're using it in a more complicated data structure, but yeah, basically it's, hey, I'm about to add 100 things and I'm not going through or yeah, I'm about to add 100 things. So ensure capacity count plus 100. Do your resizing now and get it out of my way. Especially don't grow twice.
Yeah.
So for dictionary, it's actually kind of weird because things with the same key end up being in a more complicated structure. But here, if it's really just linear space based on the count, then it seems perfectly natural to me. So
even dictionary just assume perfect distribution.
Do you think there is need to expose the actual capacity as a property?
No, I think to Jeremy's point, I think there is this interesting thing of like, what do you base it on, right? I mean, if there's any complicated math you could be doing to optimize, maybe, but people just do count plus whatever they need to add, right? And then that's just their capacity.
Yeah. And returning the capacity may tell you that there's no point in calling trim excess, but it turns out calling one instance method to avoid calling one other instance method is kind of pointless. So just call trim excess, and if you're done, and let it do what it was going to do.
Yeah, I think if trim excess exposes more things in the future, like more policies, maybe at that point you expose the capacity to allow people to do some interesting math. But if you just have trim excess with no arguments, yeah. Seems fine.
Okay.
So since we are in the bike shedding mood, so where does this thing ship? Presumably where the rest of the collections are going, or are we shipping this as a standalone thing? I mean, my personal take is I'd rather not ship it as a standalone thing because it makes everything more complicated.
Yep.
And I think like if you're already spending the time building and designing the time, we might as well ship it. In the core, I mean.
So since that doesn't seem to have an easy forthcoming answer, is there anything under here in open questions we haven't already talked about?
There might be. Let me check.
Because I know I brought up remove.
I think we've actually covered everything. So we've settled for using a value tuple for the enumerators and the constructor. I guess I don't think, do we have a sort of definitive decision on whether we should add a remove method?
I would say no.
No? Okay.
Yeah.
I
thought it sounded useful, and you convinced me it was the opposite of useful. So
yeah.
I mean, my general take is if you have a specialized data structure that has kind of concrete semantics, now you get data in and out, the whole point of the data structure is to optimize for those cases. And as soon as you throw in something in the middle where you just bypass the entire, guaranteed order of operations, then you make your implementation more complicated, and it also waters down the thing. Like,
yeah, the workaround for that, and I mean, I haven't written Dijkstra's algorithm, but if you've looked at the things that are doing it, and this sounds like it would solve it, you make a wrapper type that you can mark as this is a dead element, and then you just add a new wrapper type with the new priority. So you don't need to remove anything. You just need to yourself have already been able to find a reference to it and mark it as dead. The fact that you wanted to update something means you already knew how to find it. So I think that there's an easy enough workaround for that scenario, given that remove gets complicated with redundant elements.
Yeah. What about contains? It would also be a linear time operation, but it wouldn't contain the ambiguities of remove for obvious reasons.
Fair enough. Is there a reasonable scenario for it that isn't just like, if it's going to be an order, if it's an ON scan, then maybe it's just better for somebody to use the iterator.
I mean,
that's a fair point.
I would say contains in almost all cases is a linear scan, right? So I think if contains is a simple linear scan, I would argue that's probably not terrible to have. I mean, funny enough, even stack has contains, which is odd, but it's true.
I think the only problem with both contains and remove is that it then sort of starts the conversation about whether we should make the constructors optionally accept an I-equality comparer for the element. And personally, I don't want to go there. But
yeah, so I think with contain, if we added contains, we would have it should optionally take the I-equality comparer. But I think until we have a solid scenario for why someone would want it, and it's just a linear scan, that going through the unordered elements property seems like you can solve your scenario, and it's with essentially the same perf.
Mm-hmm.
That's true. Although, like, I just want to point out that on Stack, 11% of people are calling contains. So that is surprising. And then on Q, it's 5.5%. So it seems like people do it more often than you think.
Oh, we should encourage it.
I mean, honestly, I'm more okay with contains because it seems, it's a pretty straightforward implementation, right? And it's hard to imagine a data structure that couldn't do a linear scan, right? Remove is more problematic because now you have to think about how you shuffle data around.
Well, that's not an issue. Like, it's a log n operation that would, behave in the same way as, another heap implementation that supports priority updates. The only problem here is the ambiguity of containing duplicates.
For contains or for remove?
For remove, like the operation to, there's no issue with removing an arbitrary element from the heap. Like you follow the standard heap modification operations that take log n time. The only problem is actually finding that element in the heap. That's sort of the thing that takes the linear scan.
I see. Yeah, I would start with not doing remove, and I mean contains. I would be okay with adding it because it seems enough people are using it already in other data structures. But
I would add also that adding a remove method doesn't negatively impair like the performance of people that use the regular methods.
Yeah, I mean, I think remove we decided was complicated, so we should leave out. And then without remove, I guess contains feels weird to have without remove, and you can solve it via another method. Another means. And if people say, hey, here's the reason that I need to check contains and needing to write this long expression, which is really just contains, so I've made an extension method, why don't you add it on the type? Then now we understand the scenario and we can promote it. But I don't think there's a scenario for it.
I mean, the most common case where I would have probably used it is just debugging code, right? Writing asserts, right?
Yeah, but it's just, pq.unsorted items dot select p or e comma p goes to e dot contains whatever. Like, it's simple.
Sure. It's only 40 characters.
Right. Yeah, I mean, if you feel like we should really add it,
as I said, I don't feel strongly enough to fight for it. It just seems pretty straightforward, so I don't have any concerns with it.
Yeah, I mean, I guess I could buy the interactive, like you're in an interactive debugger and you're like, hey, thing, do you actually contains this? Because the interactive debugger doesn't always like pandas.
Yeah, using linkers in the debugger is a bit of a pain in the ass. So, yeah.
So, I can buy it for debuggability.
All right, I add a note, consider adding contains. The other ones we talked about, right? Key value
I think
pair.
it's all covered.
Yeah. We talked about T-key, T-value. Yeah.
All right. So is anyone but me upset by the notion that a thing called priority queue doesn't guarantee queue semantics for two items with the same priority?
No.
No.
Nope.
All right.
I don't care, honestly. Like, I think, to me, when you call a priority queue, I think it's important to have queuing semantics for a given priority, but if they have the same priority, I don't care.
Yeah, I should also point out that all the other priority queue implementations in standard libraries have the same issue, and it's just an artifact of the array heap that all of those implementations use. So
fair enough. Every priority queue that I've ever written was just, the priority was an index into an array of queues, and certainly in my data structures class, my prof beat into me that FIFO and queue are the same word. So
it seems like there are kind of two types of priority queues. Perhaps there's one where you've got a very small handful of priorities, right? And it's mostly a queue with a couple priorities. And then there's one where it's mostly about priorities. Everything has its own priority, and having the same priority is actually fairly unusual. And so you don't really care how that works. And it seems like this is more the latter, which is fine. We just should set expectations properly.
Right. And everywhere that I've ever wanted a priority queue, it's, 5 priorities is the most you would ever have instead of, 2 to the 64.
Yeah, that said, I do wonder if you're not better off just having 5 queues in that case. You know what I mean?
Indeed.
But by the way, I agree that that's probably a much more common user scenario. Like I've got high priority work and I've got low priority work, and I want them to be. I want to have queue semantics for both of those, but I also want the high priority work to take precedence over the low priority work. I don't think this is the data structure for that, though.
Yeah, and so that's where it's do we, agree that this is a reasonable data structure that has these semantics, but that it should use a word other than queue. Priority bag was the thing that got suggested in the issue after I brought up that I don't like that it's a queue that isn't a queue. But
I think the common parlance is priority queue, isn't it? Even if that's not, I don't know.
Yeah, and to rehash things that I wrote on the issue, Wikipedia for queue is a FIFO, and if you look at FIFO, it's like this is called a queue, and then if you look at priority queue, it's like some implementations are a queue and some are not.
Yeah, but I mean, when queue is used with other stuff, it doesn't maintain that meaning. Like work stealing queue is explicitly not FIFO. Right? Priority queue, it varies. So I think if queue alone, maybe, but queue in other contexts, kind of have to give up on that. I similarly, in college, my first professor in computer science drilled into me that the word recurse meant to swear again, and the proper word is recur. I've had to give up on that in real code bases as well.
I thought he was just saying he didn't like recursive algorithms.
Nope. They're fine as long
recurse.
as you recur.
You now have 2 problems. Your mother smacks you again. Okay, I mean, if I'm the odd bearer, I really, really, really hope that I never call anyone that uses this for their phone, customer service phone ordering.
Maybe
I had better
repeating.
wait times if I got assigned randomly.
I was about to say, when was the
Well,
last
it does
time
feel
you
like
got
I've been
parity
assigned
order
random.
semantics?
Repeating something that has already been stated in the comments, it is relatively straightforward for users to obtain the stability invariant, and that is typically done by making the priority a more complex type. For example, making it a tuple, where sort of the first element is the actual priority, and the second element is a number like the sort of the order of something being enqueued or its timestamp or what have you.
Yeah. I guess honestly, I don't care if 10 things, using timestamp, if 10 things come in within the same 15 millisecond window, the order that they get served in, because the order you got the lock was ambiguous at that point. So, assuming semi-concurrency. So yeah.
All right, is there anything else? Or can we consider this approved with the comments that I have?
So since I haven't seen what your notes say, so we got rid of elements and we replaced element collection with unordered items collection, and then had a property unordered items.
Yeah, so just added it to the screen.
Okay, then your Teams is frozen.
Yeah, your Teams is frozen in there.
Okay, in this case, I now blame Teams because I'm running on my brand new computer, so it's not a problem of resources anymore.
Yeah. Ah, so looking at YouTube.
So many windows to choose from. I think it's this one.
So your first bullet, adding queue range IEnumerable T element values needs a comma T priority.
Sorry, my first.
The first bullet in your notes. So we have in queue range that takes an enumerable of
I see.
the tuple element and priority.
Sorry.
And then the thing we were adding was an enumerable of elements with a common priority.
Yep. I was thinking that, but not writing it.
Yeah. Now, if you're doing the well-ordered semantics of having sub-priorities on items, then you would never use that one. But if you are apparently in the case where you're happy with any priority 7 item, then that one works.
So which interface implementation, or which interfaces do we still end up implementing here?
None.
Probably none, yeah. I mean, we can probably implement... Yeah, no, because they're all root in IEnumerable, right?
Yeah.
Do we have other system.collections.generic collections that don't implement iCollection?
Yeah.
Be surprised if the answer was anything other than no.
Key value pair.
That's not a type.
Yeah.
It's in system collections generic.
Yeah, that's a helper.
Yeah, even the even the immutable collections ended up implementing most of them because we just implement them with read-only semantics.
It does still feel like a generic collection, though, but...
Honestly, I'm kind of okay with it. Like, it's not like... to me, the implementing is not the higher order bit, right? It's the... Can it be used with an IEnumerable semantics? And the answer is yes, right? You just index into it, right? You just don't get it directly on the type.
It just feels so weird.
Yeah, I don't disagree with you, but
And we're doing this purely because we're concerned around having a name for ordering.
Yep.
pretty
Because
much.
I really agree with Emo that for each item in priority queue, or each item comma priority in priority queue, really feels like that's going to be the DQ iterator, and that will just be a bug farm. So not having that compile feels to me more valuable than the consistency of all types that aren't used by other types in system collections generic or IEnumerable.
I mean, if you really feel strongly, I mean, I don't have any objection with putting it in system collections specialized, right? Where not everything implements this. So for example, bitvector32 doesn't implement anything either. It's just a bit weird to use system collections specialized because we think of it as the, weird collections on the out of the V1 time frame. But I mean, it is a very
my
specialized
concern with not
collection.
implementing interface has nothing to do with the namespace. I just think it's strange to not implement the interface. It's a collection. All of our collections, all of our meaningful collections implement IEnumerable. But I've said my piece.
Yeah, I mean, so how do you explain this to a customer then? I guess would be my question.
Same as with dictionary. It gives you back the contents, but the order is arbitrary.
Yeah, I mean, why do you use IEnumerable on a dictionary? probably for stuff like dumping it out or saving it to persisting it somewhere. I think the exact arguments that apply to dictionary apply here too, don't they?
But I think that we often see complaints from users that if they add 4 items to a dictionary and they for each it's in the order that they added them. And when they add 400 items, it's not. And they're like, this is weird and inconsistent, you should fix it. And by fix it, they don't mean make it always be random, they mean make it always be determinate, or make it always be the thing they want it to be.
I'm surprised that when they add 4 items to a dictionary, they get it back in that order.
Yeah, that seems like it happens one time in 16, right?
I mean,
I maybe you're looking at different issues than I am. I haven't seen that complaint, and if that complaint comes up, it's like the answer is simple: don't do that. You're not going to get the results you expect.
I think it's if you have like a dictionary of int where the hash codes are predictable, as in it's itself. Then the first couple of the buckets end up being ordered, and it walks the buckets in the bucket order, and your items are all understandable because your capacity was big enough that you don't have bucket sharing.
Well, then let me ask you this then. Are we okay with saying if we implement IEnumerable, we are okay with paying the overhead of whatever it costs to actually order them?
No. I think the main problem here stems from the fact that, enumerating a regular queue guarantees ordering. So I think people might just, copy and paste some code that consumes a queue and expect that, the same thing will happen with priority queue. I think that's the biggest risk. So I would certainly think that we should use the property instead.
I mean, but like maybe that's a dumb question, but why we're not okay with that? Because if you don't want to pay the overhead, then you have to use the property. If you just want it for each, sure you can. It's just more expensive.
Well, because now the easier to write code maybe there is the complicated performance code.
Right, but I mean, I don't know. Like, it seems to me, I don't know. Like, so what's the cost overhead? Is it O(n) allocation, or is it
order n log n in time and order n in space?
I mean, that's my quote for. Was it like the Chernobyl series, right? Not great, not terrible, right? Like it seems like for correct code, maybe that's not too terrible, right?
Well, wouldn't we rather?
That's like saying anytime anyone writes a for each, you clone the collection and sort it.
Right, but isn't that what some of the concurrent collections do to have snapshot semantics?
Concurrent queue does not. Concurrent stack does not. Concurrent dictionary does not.
Yeah, but one of them did, right? Or am I just missing?
Concurrent bag, and it's very rarely used because it's got poor behavior there.
Yeah, I mean, it seems to me like if we were to do this, I mean, we can't. I mean, it's early for 6, right? So like, I mean, I'm okay with experimenting, right? I mean, okay with saying, let's revisit this and see what happens. The only problem is if we just wait for signal and the signal doesn't come, that doesn't mean that people are not surprised. It might just mean that people are not actually using the collection. But I'd be shocked if people will not stumble over this as a behavior.
I mean, I think that we have in versions of .NET Core that tell us that we get much better feedback 3 days after we ship than we do for the entire preview period. So I don't know that we can have a data-driven thing by saying, oh, this will be in all the previews. They can tell us we did it wrong, but they can't tell us we did it right.
Yeah, I mean, like one thing we can do is, not implementing IEnumerable and see who complains, right? And when they complain, we can talk to them and say, what is your scenario? And then we can judge ourselves, would this code have worked with the semantics we have in mind?
Mm-hmm.
That seems the most, or the least riskiest and the most easiest to drive from a data perspective. I mean,
but assuming we roll back, would we then delete the property as well, or is that not an option?
Well, it kind of depends on what we do, right? So if we go with what I said, it would still add value. If you go with what Steven said, then you have two ways of doing the same thing, which is not entirely horrible, right? Because you could still argue the person who does it, they can just say, well, it's clearer if I add the dot unordered items in the middle, right? It would be a bit unfortunate, but it also wouldn't be terrible. But yeah, depending on when we find out, right? If we find out like in the middle of .NET 6, I think it's okay to remove the property. If we find it out literally in the RC, well then maybe not, because then we are done with breaking changes, right? But if you want to write it super safe, I'm also okay with saying we don't add the property and we don't add the interface, and you just can't do it at all.
Well, I think that's a problem, because now there's no way that you can take the state of your queue. I guess you could. You keep calling try dequeue and you drain everything out of it. But you're making it hard to do process save and load if you can't enumerate it at all.
Right.
So yeah, I guess my preference would be the unsorted items. The type is not enumerable, and if we get feedback where people want it to be enumerable, that's an easier change than if we had it being enumerable and it's confusing people. And if we get the feedback and people are all like, oh yeah, I totally expect that I'm enumerating the things and it's a garbage order and that totally makes sense, then we'll ship that, and then 2 days after ship we'll have a bunch of bugs of, hey, this doesn't order correctly. And it'll be .NET 6's version of we changed what double.toString does.
By the way, I have the impression though that the order that is currently being returned isn't entirely garbage, because I believe it's the optimal sequence when you perform a heapify operation. So I believe that if you were to, for example, serialize priority queue, if you were to reconstruct the priority queue on deserialization, then it would perform fewer comparison operations, because it wouldn't need to rearrange the elements. They would already satisfy the heap property.
I mean, that's probably the biggest argument for implementing interfaces, is that unless serializers are special casing this type, you wouldn't be able to serialize it by default in almost any serializer.
Right.
Fair enough. I mean, I think but making it be enumerable then has does it guarantee DQ order, which I think Steve will have strong opinions about, and I might even agree with them. Wow, I picked a perf over usability. Yeah, so if it's not sorted, it'll confuse people, and if it's sorted, it's expensive. So, yeah, that's why I like the property, but I'm just restating that so we're not forgetting why we got there, and if people feel strongly, then I don't super care. Someone else should talk. I keep trying to fill the vacuum.
Yeah, I think if we can get this shipped in the early previews, then we can certainly pivot if feedback is overwhelmingly negative.
Yeah, so far I've not heard anybody with saying I will object shipping the type unless it implements an interface. Or did I mishear what people said?
I heard it was weird, but not a...
Yeah, not deal breaker weird, right? I mean, it is a very specialized collection, right? I mean, if we plot all the people in the world that use it, we are probably talking about like, yeah, what is it, less than 5% probably, right? So I'm okay with saying, yeah, it's a specialized type and it comes with specialized semantics.
What if we plot how many people have to do it as a whiteboarding question?
Eric, I assume the elements property returns is lazily initialized and returns the same collection every access.
Not in my prototype, but yeah, that should be the case in prod. So basically, it's following the same semantics as the dictionary nested collection types.
Right. Or unsorted items, whatever we've now called it.
Yeah.
Is it an actual class or wasn't that a struct? I thought it was a struct. No? Oh no, it was a class. Never mind. Yeah, please don't allocate every single time somebody requests that. All right, so then this is it for now. Only took 5 years, but
Yay.
yeah, it's the little kid gif, right? Yay. All right. Then I think we can look at other things in the backlog. Does anybody have a particular item they want to look at?
I guess I have one question as we're shutting that down. With the unordered items, we had a property. So presumably that means it's giving back the same object, the same allocated thing on every call. So does that mean that I guess its get enumerator is snapshots of what the collection looks like at the time. So you can grab the collection, add to the priority queue and iterate again, add to the priority queue and iterate again, and that doesn't throw. But if you're in the for each when you add, then that throws.
They behave exactly like if you were for eaching the type itself.
Yeah.
Yep.
Right, but so it's you can hold the reference type it gives back, and you can for each that multiple times as long as you're not still for eaching it while you're modifying it.
Right. The thing it gives back, like the implementation,
Is,
I don't know what
is
Eric
return
does,
this.
but it just does, underscore priority queue dot get enumerator, right? And in this case, we just so happen we made get enumerator private. But,
Right. Okay. I'm just yes. That was the last little thing sitting in my head because there was a comment from YouTube of does elements allocate a copy, but it's not. It's just it's giving you this under a different type so that you had to walk through a name to get to it, essentially.
Just like keys and values on dictionary.
Yeah. Okay, so I'm just making sure we're being consistent with what it means to be a collection property and what it means to have concurrent iteration. And it sounds like that's solved, so moving on.
But to be clear, like doesn't necessarily mean that the enumerator is private, right? You could still have a nested type under unordered items collection that does the same optimization that we currently have, right?
I'm not requiring any implementation. I'm just saying like a trivial, like this is really just exposing this via a name.
Right.
And the simplest way to do that would, just be to have the new type and its get enumerator just delegates, right? But that's just an implementation detail.
Yeah. It's logically the same as that, but then with some complicated structure because of where the types need to be public and nested.
Right. So because we're exposing a struct enumerator, most likely is we would, and assuming we want it nested under element collection, most likely it would just have internals access to, or privates, it's a nested type, so it has privates access to everything in the parent priority queue. So it has a reference to the priority queue and just accesses it directly.
I'll fix your indentation, Emo.
What have I done this time?
You put that bullet under why the type isn't enumerable instead of under the bullet of, I mean, it's literally under the bullet of unordered items, but I think you meant it as a sub-bullet.
Sure. Like I meant what I typed, but I can see the other explanation as well.
Yeah.
Maybe it's just me, but like after 2 levels of nesting, I kind of give up. All right, so 50 minutes left. Nobody has a favorite item?
I've got some probably small numerics ones.
Sure, go for it. Which one?
43169 and 43733.
So this one here, the differem one, the roundup, this one. Oh, probably they're all in the same bucket.
Signcos and overloads for inint, inuint.
So they just do both at the same time, is that it?
I cannot see your screen, Mo.
Oh, sorry. Yeah, I can't share because Teams is again in the mode where I cannot share anything anymore. Like it just stops working.
Which one are you on first?
I'm on 43169.
Okay, yeah. So Signcos is an API that native compilers either provide directly or they implement as an optimization. Where if they detect sign and cos called near each other, it will just compute both at once. It's an optimization useful for a lot of various APIs that end up requiring one or both methods. Because when you compute one, you generally need the other, and computing both simultaneously is considerably cheaper than computing them independently. There's 3 proposed shapes for the API here. The first one is we just return both as outputs. The second one is we return one value and we out the other. And you'd have to recognize it by name. This kind of matches how divrem works today. And the third is we return both as a value tuple, which is the actual one I think we should do, as that's the one that the JIT will optimize with the recent changes that have gone in.
Yeah, I was going to ask of, given that the reason for adding this is a perf improvement, which one works better with the register allocator?
Yep, and that's the one that returns a tuple.
Yeah, to me it also makes the most sense. I mean, you basically ask for an operation that gives you back 2 values. It's always going to be 2 values, so tuple seems totally fine here.
Yep. And then, of course, there's no guarantee that this will be fast. On platforms where it can be fast, it will be fast. But in the worst case, it will be no worse than just calling sign and cos consecutively.
Yeah, makes sense. I mean, if you discard one of them, you're doing it wrong anyways, right? So
yeah,
you only have to handle the case where it's that, yeah.
I mean, in the case where basically it's implemented as calling sign then cosine, that may be slightly more register and stack spill than you doing yourself in caller code.
But shouldn't be.
But yeah, if the register allocator plays nicely with the value tuple return, especially if it plays nice early with the value tuple return, then I'll reluctantly agree that that's a good use of value tuple.
Does the register allocator only work nicely when you deconstruct immediately, or does it also handle it when you just index into the tuple?
I would probably have to talk to Carol to determine how she implemented it.
I'll ask the same question I always do, which is, does it have well-defined behavior when it sees not a number, infinity, blah, blah, blah?
Yes.
Okay.
Those are strictly specified by the IEEE specification, and for those edge cases, we have strict tests that validate they are correct.
Awesome.
And I guess more importantly, in those boundary cases, they will behave the same as the sine and cosine methods.
Yes, and
Okay.
The tests that we end up adding will validate that as well.
Sweet. So then the next one that I had open was 42156. System life.
It was that one is there too, but I was 43733 might be a better one to look at first. They're semi-related.
At least the NIND and NUINT ones.
Yeah. These are basically both just proposals to expose missing APIs, but the inint ones have actually been requested for real scenarios, whereas the unsigned ones, they've had fewer requests from the community overall. So for 43733, it's basically we expose several math APIs that work with all of the existing integral types: byte, sbyte, short, ushort, int, uint, long, ulong. Now that we actually have native integer as well as a new primitive type, we should expose these abs, absolute value, clamp, divrem, max, min, and sign for these as well. With sign and absolute value and divrem being only for the sign types to match how it is for int versus long.
So it seems like
int versus uint.
Giving it a quick scan, the only thing that seems to be missing is big mul.
Yeah, so big mul doesn't make sense because big mul is taking an input of 1 precision and returning an output that's twice the precision. So 32 bits and returning 64, or 64 bits and returning 128. You can't really define that for inint because you don't know what double the size would be.
Gotcha.
You probably could, but I also don't think that's as useful.
No, makes sense.
I think you'd have to return half the result and then out the other half, both as the input type, like we're doing with long today.
And then parameter naming wise, I suppose we copied the existing ones, right?
Right. With divrem, it might be nice if we changed it to remainder as the result instead of result, and left and right for instead of A and B. Just right. Because it always comes out that's confusing. Right. The other thing with divrem is that it's matching the existing signature for consistency, but returning a value tuple would be clearer and produce better code gen moving forward. So that's a decision of, should we be consistent with the existing integral overloads, or should we just go ahead and make that break, which is what the 42156 was going over.
So then we are okay with this one here as is. So let me just copy paste what I just said.
Switching to the video so I can see what you're copying and pasting.
You're copying and pasting the proposal as is, right?
Yes.
Okay.
And so we'll take divrem consistent with how we're exposing the other ones.
Whatever was in the proposal, yeah.
Yeah. Okay.
Yeah, though I will say, and I know you use divrem as a example of a multi-value return. The fact that it outs a thing called result means I have to look up what it does every time.
Yep. It's a case where I would be strongly in favor of taking the breaking change to rename it to quote or remainder.
Yeah, I mean we can. So there's another proposal for that, right?
Yeah. The 42156 is covering. We don't expose divrem for any of the unsigned types. And it covers the value tuple pattern is the thing that's better for code gen, and maybe we should just expose all of them like that moving forward.
Sorry, that was 42156.
Yeah, the one that you're on.
Yeah, so why is that a different pattern? That's the pattern we already have, right? That does the out. I thought the proposal was to do something different.
So the proposal covers two parts. One is we're missing these overloads,
right?
Especially for the unsigned types. And then at the bottom, I called out that the value tuple pattern is the pattern that has been optimized with the register allocator. So it's likely the pattern we should use moving forward. So it's a question of, do we want to be consistent? Do we want to expose both patterns? Or do we want to just start exposing the value tuple pattern for all these new overloads?
So I think we should, if we think, feasibility wise, I agree with Jeremy. It seems better to just have the named tuple elements would indicate which one is which, right? Which is probably more helpful. And it's more consistent. I mean, if that's what we want to do, then I would not add new overloads under the old pattern. I would just say, yeah, we only expose the new one. And we can do it for the existing ones anyway, because we can overload based on the absence of an out parameter, and that seems fine. And if we really wanted to, we can add an analyzer/fixer that suggests people to move from the old ones to the new one, right? So yeah, unless somebody has an objection to that, I think the suggestion to add diffrem for the other type seems fine, and then I would just combine the two into one API change that is basically adding the new ones. And simultaneously also add the other ones that already exist but without the out. Right. Okay, that my editing skills are not good.
So it would be.
And we probably should do it for math. I guess math F doesn't make sense because there is no floating point here.
So it would be what I've just posted.
Where did you post it?
It should refresh in a second. At the very bottom.
Oh, in the issue. I thought you pasted it in.
Yeah.
Jeremy, I assume you're okay with the names.
I think that he dropped.
Or
So I
maybe.
think that means yes. He's okay with the names.
All right, then let me just.
We can follow up with him offline.
All right.
And then I'll call out on the int overload to check that one for the value tuple pattern for divrem.
Yeah, that would be good. Right, then this is it for today. Then I see you guys next week again. Alrighty.
Thanks, Emma.
All right, bye-bye.
Thank you.